Why are stem cells so important? Stem cells are important because these are the cells that we are made of that early in our development had the potential to become anything. And what we can now do, in the past, we needed to take stem cells from a fetus, which was also ethically fraught. But we can now take stem cells from, say, your skin or from fat cells, put them in a dish. So these are mature cells, but then we could put some chemical factors in there and revert these adult cells to a stem cell-like state, and then we can nudge them to become things that we want. So we can grow up organoids. We can create synthetic meat, but it's not really synthetic because we can use the real cells coming from muscle to create this meat. But we can also plate them on microfluidic chips about the size of a thumb drive. Now, why would you want to do that? Well, let's say I took your cells and I reverted them to their earlier state. I could put them onto a drive and onto one of these microfluidic arrays, and then I could create a bunch of organ systems, a kidney, a heart, a brain, a liver, that look like you. I can run experiments on them on the chip. I can run drugs through them to see how somebody would respond. I can throw them in environments like space. NASA's doing this to see how your individual genetics and epigenome would respond to these conditions. I can also potentially use these adult stem cells as bio-ink to create and print new organs, also to help us with this organ failure. But in fact, you can use bio-ink already. There's a group in Australia that's using it to replace cartilage in people's knees. Right? So this is a way, again, that we can repair and replace things that are failing in our own bodies. But the holy grail for longevity, this is an example of using this technology to actually, it's a combination of CRISPR and stem cells and epigenomics. These are two rats, or mice I should say, that are the exact same chronological age, but you can see that the one on the left that's been edited looks much younger. And you can also use that same reprogramming technology, this came out of David Sinclair's lab, to actually replace the optic nerve. Another example is we can take cells and reprogram them to become sperm and egg.